Good morning, students. Today we'll discuss the second chapter of class 10th, polynomials. In earlier classes, we have learnt about polynomials in one variable, their degrees, factors, multiples, and zeros. In this chapter, we'll study about the geometrical representation of linear and quadratic polynomials and also the geometrical meaning of their zeros. We'll also study about the relationship between the zeros and the coefficients of a polynomial. In class 9th, you have studied polynomials in one variable and their degrees. If px is a polynomial in x, the highest power of x in px is called the degree of the polynomial. For example, 4x plus 2 is a polynomial in the variable x of degree 1. 2y square minus 3y plus 4 is a polynomial in the variable y of degree 2. And you also know a polynomial of degree 1 is called a linear polynomial. For example, 2x minus 3, here the variable is x and its degree is 1. 2y minus 7, here the degree of the variable y is 1. These are known as a linear polynomial. Similarly, a polynomial of degree 2 is called a quadratic polynomial. For example, 2x square plus 3x minus 2. Here the variable x has the highest power 2 and y square minus 2. Here the variable y has the degree 2. So these are quadratic polynomials. Similarly, if the degree or highest power of a variable is 3, this polynomial of degree 3 is known as cubic polynomial. Now, in graphical representation, you can see a graph of a linear polynomial. Suppose y is equal to ax plus b is always a straight line which intersects the x-axis at exactly one point. Here you can see the graph, and if we take a quadratic polynomial, suppose ax square plus bx plus c where a is not equal to 0, the graph of this polynomial ax square plus bx plus c has one of the two shapes, either open upwards like u sign, and in second portion you can see open downwards. These curves are called parabolas. These curves are called parabolas. Therefore, now we'll check the number of zeros. Here you can see in the first graph the number of zero is 1 as the graph intersects the x-axis at one point only. In second, you can see this curve intersects the x-axis at 1 to 2 points. Therefore, the number of zeros in this graph is 2. In third, you can see the curve intersecting the x-axis in 1, 2, 3, 4 points. Therefore, the number of zeros are 4. In fourth part, you can see a straight line intersecting the x-axis at one point only. Therefore, the number of zero is 1. Similarly, you can find in fifth part the graph or curve intersecting x-axis at only one point. the number of 0 is 1, and in the last sixth part the curve intersecting the x-axis at 1, 2, 3, 4 point. So therefore the number of zeros in sixth part is 4. So similarly you can do the exercise 2.1. Now we'll discuss the relationship between zeros and coefficients of a polynomial. So you know for that I am doing an example. Suppose a polynomial px x square minus 7x plus 12. So here you can see I am factorizing it by splitting middle terms. The factors of 12 whose sum or difference is 7 are 4 and 3, because 4 plus 3 7 and 4 into 3 12. Now it becomes 4x minus 3x plus 12. Now the common x, and here the common is minus 3, and the factors of polynomial x square minus 7x plus 12 are x minus 3 and x minus 4. So first, because we have to prove the relationship between zeros and the coefficients. So first I am finding the zeros. For finding the zeros we have to put the first part x minus 4 equal to 0, and also second part x minus 3 equal to 0. So when we put the first term or first factor as 0, we will get x equal to 4, and by putting second factor we get x equal to 3. Therefore you can see the zeros of this polynomial px are 3 and 4. So you also know, if I am taking one root as alpha, that is 3, and second root is beta is 4. So now the second part, here I am selecting the coefficients. The polynomial is x square minus 7x plus 12, and by comparing it with the standard form we can compare a is 1 first coefficient, b is minus 7, and constant term c is plus 12. So now we'll use two formulas. First is sum of zeros. This is minus coefficient of x square upon coefficient of x upon x square. It is also known as minus b upon a. And here sum of zeros are alpha, then beta, and minus b you can see minus 7, so minus minus become plus 7 upon a is 1. Now alpha is 3, beta is 4. So now you can see LHS 4 plus 3 is 7 equal to 7. LHS become equal to RHS. Now second portion, product of zeros. This is equal to constant term upon coefficient of x square. Here the product of zeros means one zero is alpha and second is beta, and constant term is 12 and coefficient of x square is 1. So now you can say alpha is 3 and beta is 4. Therefore 12 equal to 12. Again you can see LHS is equal to RHS. This is the verified. So here you can see for verifying the relationship between the zeros and the coefficient, first we will find the factors of the polynomial. Then for finding zeros we will put these two factors as equal to 0 and we will get first 0 alpha and second 0 beta. And similarly we can select the coefficients with comparing with ax square plus bx plus c. You can get a with sign b minus 7, c is plus 12. Then first we will find sum of zeros, that is minus b upon a. Then by putting the values, 7 equal to 7 means LHS equal to RHS. And second part, product of zeros, that is equal to constant term, that is c. Coefficient of x square is a, c upon a. So first product means alpha into beta equal to c is 12 and a is 1. 3 into 4, alpha is 3, beta is 4. 12 equal to 12. Again we will get LHS equal to RHS. So this is the verification of the relationship between zeros and coefficients. Now in the second part we discuss how to form a quadratic polynomial. Forming a quadratic polynomial. Now we all know if I take a quadratic polynomial ax square plus bx plus c, here you can see a is the coefficient of x square, b is the coefficient of x, and c is the constant term. So now how we form a quadratic polynomial? Suppose the zeros of this polynomial px are alpha and beta. So now we will find if alpha and beta are the zeros and these zeros are given as first 0 is alpha and second 0 is beta. So then the quadratic polynomial, we can form a quadratic polynomial by the formula x square minus sum of zeros into x plus product of zeros. Now the formula is x square sum of zeros is alpha plus beta and product is alpha beta. This is the formula for finding a quadratic polynomial when two zeros alpha and beta are given. This is the first part, and in the next video we'll discuss some questions.